All right. Well, hey kids, I hope you're having a nice weekend. This problem here is this number 28 of the SPIC book. This is the homework, and so I'm going to work a problem and hopefully help some folks out. Um, it says here phosphoric acid, and if you're unaware of what this is, it's on your oxidation sheet, and it'll tell you what the formula is for this. Magnesium hydroxide we're going to make, and it yields magnesium phosphate, which is a crystal. That means this is a precipitate, and it also gives us water in liquid form. So it turned kind of cloudy. That's what would happen to this thing. You'd start to see a crystal form. So like I said, this phosphoric acid is on your oxidation sheet, and it is H3PO4. So in other words, there's three hydrogen ions, H plus ones, and there's one of these PO4s. It's a -3. All right, and then plus, I'm going to start with the ions. If it's like a phosphoric acid or some sort of base, magnesium hydroxide, I'm not sure if it's on there, but a lot of those are on there as well. If you're unsure, you could just put down the ions. In this case here, magnesium, and it has a +2 charge, and then the hydroxide, OH -1 charge. And it yields magnesium again, Mg +2, and then the phosphate PO4 -3, and then it gives us water. And I'm going to write it out the way I told you, H plus 1 OH -1. Okay, so I'm just going to take another page here, and I'm going to take this magnesium hydroxide just to kind of go back and revisit what we had already said. So I had a magnesium +2 and then a hydroxide -1. This should be a plus here. And what I'm going to do is I'm going to take and I'm going to cross over. I'm going to bring this 2 down as a subscript here and bring this 1 down as a subscript for magnesium. I'm going to cross them over to the opposite one. So it becomes Mg subscript 1 OH, and since it is a polyatomic, I need the parentheses. I put the subscript 2. That's what it looks like. So after you're done, it should be Mg parentheses OH subscript 2. That's what it'll look like. So let's go ahead and go back to our sheet. So I'm going to write it in H3PO4 plus, and we did this one already, Mg, and then OH subscript 2. Then I'm going to do the same here. I'll do another sheet. I'll get another sheet here for us so that we can take a look. It should be, let me show you what it is. Let me get rid of this stuff. Here we go. Magnesium +2, and then phosphate, which is PO4 -3. And then I'll use a different color if that helps out. Maybe I'll do like, oh, I'll do this blue here. So then I'm going to cross it over. I'm going to take this 2, and it's going to become the subscript for the PO4. And then the 3 on the PO4 is going to become the subscript for the magnesium. Just cross it over like that. Let me see here. And I'll go back to the black one. And then when I rewrite it, it looks like this. So magnesium, and I'm going to take this subscript here, 3, right there. And then PO4, remember it is a polyatomic, so I need to put it in parentheses, and its subscript is going to be 2. And the reason being, if I have 3 magnesiums, 3 times 2 is 6. And same over here, since PO4 is -3, I have 2 of them. 2 times -3 is -6. So net charge is 0. So that's how it all works out. And we just kind of like to double check everything. So I'll write it out here. It should be Mg 3, and then, oops, PO4 subscript 2. And then this becomes our water, HOH. Okay, so now I'm going to just change colors so that we can see our coefficients, because now that we have everything, we've bounced out all the formulas, all the compounds are bounced out with the subscripts. I'm going to balance the equation with coefficients. So let's take a look. So I'm just going to kind of outline everything, just take a quick look and see what our plan of attack is. There's 3 hydrogens here, there's 1 hydrogen here. So right there I know that we're a little deficient. We're going to need to change that. And then there are 2 hydroxides here, and there's only 1 here. So we're going to have to kind of be real careful about what we do here, what we choose to make happen. So and then the magnesium, there's 1 here and there's 3 over here, and I think that's where we may start. That looks like a good plan of attack. The phosphate, there's 2 here and there's 1 over here. So I'm going to start here with the magnesiums and see how this goes, and then we'll kind of work it on out from there. So since I have 3 on the right here, I'm going to put 3 over here. And the reason why I started here is because I noticed that the OH here, on this side there's only 1, on the right hand side there's only 1, and over here there's 2. And then I noticed that there's 3 here, so it's kind of like, well, how do I get this thing started? So we're going to check this out. We're going to see what we can do. So right away, there are 6 here. It says here that there's 3 magnesiums, good, and then 3 times 2 is 6, so the hydroxides, there are 6 of these. There are 6 of these. So to kind of balance that out, I'm going to put a 6 here. Now again, if you're wrong, you can always go back and erase and start a new spot. You know what I mean? Practice makes perfect. So don't be, scared if you did a different way. But this just tells me I have now 6 hydrogens and my hydroxides are balanced out. So I can go all the way over here and I can put a 2 in front of the hydrogen. What that does is it now gives me a 6. So it's H subscript 3 times 2, which is 6, and I have 2 phosphates. And lo and behold, there's 2 here. So let's kind of go through everything and make sure we're all balanced. There's 3 magnesiums. I put a 3 here, there's 3 magnesiums. Okay, the 3 out in front means there's 6 hydroxides because of the subscript 2. There's 6 of those. And then I went to the hydroxide and I put a 6 in front of it here. And I have 6 hydroxides, so that's balanced, but it also raised my hydrogens to 6. And if I'd gone over here and I put a 2 in front, that means because of the subscript 3, I have 6 hydrogens. It also means I have 2 phosphates. If I go back over to the right, I have 2 phosphates as well. So everything pretty much checks out. I'm pretty happy with it. I'll kind of go over it really quick so that you're not left in the dark. Just to kind of reiterate, I didn't start with the hydrogens because of this hydroxide situation, and also because it's a 3. I know it sounds funny, but I looked at it, I said H3, so if I put a 3 out in front here, I know I'm going to run into trouble because the hydroxide would be 3 and there's 2 here. So that's why I opted to start with magnesium, because whatever the magnesium balances out, it's going to raise the hydroxide and make it a little bit more manageable over here. I don't know if that makes any sense, but it's just more practice makes perfect, and it's kind of like looking at what you have on both sides and finding the best plan of attack. So just keep trying, keep wiggling stuff around, and then when you find your final answer, I'm going to rewrite it so that it all looks nice and neat. Here it is. So how it reads so far is 2 moles of phosphoric acid plus 3 moles of magnesium hydroxide yields 1 mole of magnesium phosphate plus 6 moles of water. And you can write it out this other way after it's all done if you'd like to do it that way. Either way, you can leave it all the same. You can also add the little states of matter. This one here is a crystal. This is aqueous, meaning it's a solution, and this too is a solution. Okay, it's an acid-base reaction, and that's why we got the crystal. I hope that helps out. I can quickly go over it really quick again. 6 hydrogens, 6 hydrogens. There are 2 phosphates. There are 2 phosphates here. There are 3 magnesiums, 3 magnesiums, 2 hydroxides, 6 hydroxides, and then 6 hydroxides. And that's your final answer, kids. And if you'd like to kind of like circle your answer, I think that's good practice, especially coming for test time, so that I can see your answer clearly. And this one is also a double displacement, just to kind of add that in there. That's what's coming up tomorrow. So kids, I hope you had a nice weekend, and I hope you get this finished. I look forward to seeing you tomorrow. Take